In this video, I want to show you how to solve an inequality. And the way I'm going to go about doing that is first by showing you some key differences between equations with an equal sign and inequalities with a greater than or equal, And then I'll go ahead and take you through the solving process so you can see the nuts and bolts of exactly what you need to do. Now, after that, I'll take you into some compound inequalities that really involve putting more than one inequality together. So let's first start off with some of those obvious differences. When you're looking at an equation, there's a giant equal sign in there somewhere. And when you're looking at an inequality, then you have one of these symbols, such as greater than or equal to, or less than or equal to. And so it should be pretty clear just by looking at one of these what case you're dealing with, equation versus inequality. Well, let's start to go beyond that to see really why these are very, very different. And really to do that, we'll look at the solutions that you get from an equation versus the solutions you get when you're dealing with an inequality. Okay, so down below I have some examples. In the first one I have 3x equals 15. So think for a bit, what is the solution of that equation? Well, hopefully it doesn't take you long to see that x equals 5. Now think about that solution for a bit. You only get one little isolated point, that x is equal to 5. And x doesn't equal anything else, just that little single point. Well, some equations might actually have more than one solution. So just having one single solution isn't quite the key difference. In fact, look at my next example, x squared equals 9. For this one, it actually has two solutions, -3 and +3. But again, think about those solutions and notice how they're two very isolated points. Nothing else is around them. Just -3 or +3 will be a solution. All right? Now lastly, let's look at this inequality. 4x is greater than or equal to 8. Now, when you look at this, notice how lots and lots and lots of different x's can be used as a solution. For example, if x is equal to 2, then you would have 8 is greater than or equal to 8. Which is true. You could even have something just a hair larger, like 2.3, and that's still a solution. So is 2.4 and 2.5 and 7 and 10. You get a whole range of solutions that works. Well, that idea of coming up with a range of solutions is really key when going through the solving process. Now, since our solutions are basically a whole range of numbers rather than isolated points, we need special notation in order to describe these different solutions. And so down below I have some different ways that you'll see the solutions described. One of the first ways actually just uses one of these inequality symbols. For example, if I'm trying to describe all the numbers that are strictly less than 4, I could use this, x is less than 4. And, that would be one way to describe that solution. Of course, there are many other ways as well. When we're working with domains, we used interval notation. And this would be another way to describe every number that is less than 4. As you can see, it goes from -infinity all the way up to 4, but does not include it, since it has that parentheses. Well, here's another way that's a little bit more visual. On a number line, you could shade in all the numbers that are less than 4, and then either put a circle or parentheses right at that 4 to show that it is not included. And of course, that's yet another way. And lastly, we have what is known as set builder notation. And this may look a little bit unfamiliar. The way set builder notation works is it first describes a set of objects using a variable. So that first part there that says x, that's just describing what variable we're going to use. And then you might notice a vertical line. That separates the variable from the rules placed on that variable. So we're dealing with x's such that these x's must be less than 4. And so you can really see that, yes, it's the same as all of these other descriptions here. That you're really just trying to collect together all of the numbers that are less than 4. Let's get into the nuts and bolts of how you actually go about solving one of these inequalities. The good news is that you really use the same techniques for solving an inequality as the techniques you use for solving an equation, with one additional rule. Whenever you multiply or divide by a negative number, you want to flip that inequality symbol in the middle. So not only will you be doing things to both sides of your inequality, keeping things nice and balanced, but if you end up multiplying or dividing by a negative, just go ahead and flip that sign. Let's give it a try with a couple of examples. On the left, I have 3x minus 5 is less than 6 minus 2x. Now, just when I was solving equations, I noticed that I have two x's, which means I'm going to work to get these guys together and then try and isolate that x. So let's give it a try. In my first step, I'm going to add 2x to both sides. So this will give me a 5x minus 5 is less than 6. So just like that, I've combined my x's. Now I'm going to work to try and isolate that x. So in my next step, I will add 5 to both sides. All right, that's looking pretty good. For my last step, I will divide both sides by a 5. Now in that step, I do pause for a moment and I go, wait a minute, I'm dividing by something. Is it negative? Well, in this case, since I'm dividing by a positive number, there will be no change in the sign in between. So my final answer is all the numbers that are less than 11/5. Just like that. Now, if you want to describe this using an interval, I would use the interval that goes from negative infinity all the way up to 11/5, and then I'd use a parenthesis on that 11/5 to show that it is not included. Now let's give the second example a try. This one is 13 minus 7x is greater than or equal to 10x minus 4. And you'll notice with this one again that I have two x's that I need to get together. Well, in order to get them together, I'm going to subtract a 10x from both sides. This will leave me with 13 minus 17x is greater than or equal to a minus 4. All right, so it looks pretty good. Now that we have a single x, let's isolate it. We'll start by subtracting a 13 from both sides. And that'll give us a minus 17x is greater than or equal to a minus 17. All right, we're almost home free. Lastly, let's divide both sides by a negative 17. Now be careful. Notice how we're dividing by a negative number. That's that special rule that says, okay, let's go ahead and flip the sign in addition to just doing the division. So what this will give us is that x is less than or equal to a positive 1. Since negative 17 divided by negative 17 is a positive 1. And there you go. That is my solution. If you want to describe this using an interval, then you could use the interval that goes from negative infinity all the way up to 1, and then use a bracket on the 1 to show that it is included. As you can see, solving inequalities is not too bad. As long as you remember that additional rule to flip the sign, you're pretty much home free. So let's go ahead and talk about compound inequalities when you can start putting more than one inequality together. In this first compound inequality, we can connect them using the word and. Now, this is used for situations where both inequalities basically have a similar piece. So if I have 5x is less than or equal to a minus 3 plus 11x, and minus 3 plus 11x is less than 8, well, since they have that common piece in between, I can combine them together into a single inequality. Now, you'll notice with this one, it has 3 different pieces to it. Well, in order to solve this one, I use pretty much the techniques before. But I have to remember that since it has 3 pieces to it, that whatever I do to one piece, I have to do it to the other 2 as well. Furthermore, that if I multiply or divide by a negative, that now I have to flip both of the signs that are connecting them. So I have to remember those 2 additional things. The other compound inequality connects things in a slightly different way. This takes 2 inequalities and it combines them using the word or. Now in this case, we don't actually put the 2 inequalities together. They actually stay separate. But where we do start connecting things is when we get down to the solution or the intervals at the end. So down below, as you can see, they both have a minus 3 plus 11x, but I'm not necessarily going to put them into a single inequality. So just something to keep in mind. All right, let's try a couple of more examples. On the left, I have negative 3 is less than 2x plus 5 is less than or equal to 7. And you can see this is one of those compound inequalities that has been connected using the word and. So I've already kind of put it together into its 3 pieces. In order to solve this one, I need to get the x all alone in that middle piece. So the first thing I'm going to do is subtract 5 from all three pieces. This will give me a negative 8 is less than 2x is less than or equal to 2. Finally, I'm going to divide all of my pieces by 2. This will leave me with negative 4 is less than x is less than or equal to a 1. So now that the x is isolated in that little middle section, I basically have my solution. The way I can describe this using an interval is that I can include all the numbers between negative and 4 all the way up to 1. So I have negative 4 with a parentheses, comma, all the way up to 1. And I use a bracket because it is okay to include that 1. Let's turn our attention to the second example. In this one, I have 2x minus 5 is less than or equal to a negative 7, or 2x minus 5 is greater than 1. So I don't actually put these two guys together. Instead, I'm going to solve each of these inequalities separately, and then I'm going to work on putting their solutions together. So let's see how this works. I'm first going to focus on the 2x minus 5 is less than or equal to negative 7, and just solve that one. So I'll go ahead and I'll add 5 to both sides, and then I'll divide both sides by 2. This will give me that x is less than or equal to a negative 1. So that's one of my solution ranges, and now I focus on the other inequality. 2x minus 5 is greater than 1. So to solve this one, I need to add 5 to both sides and then divide by 2. Alright, this will give me that x is greater than 3. Now here's where the combining of solutions comes into play. I'm going to combine that x is less than or equal to a negative 1, or x is greater than 3. I basically have two different intervals to describe. The first interval describes all the numbers that are less than negative 1, and I include that negative 1. And the other interval includes all the numbers that are greater than 3, but that one doesn't include the 3. And notice how that u shows up in between them? That u stands for the word or. So my solution could be in the first interval, or it could be in the second interval.